NVIDIA Blackwell RTX 50 GPU Architecture Detailed Advanced Cores, DLSS 4, Next General Gaming Technologies and more. At CES 2025, NVIDIA offered us a deep dive of its next-gen Blackwell GPU architecture for RTX 50 gaming GPUs and how it improves upon ADA. NVIDIA Force RTX 50 Blackwell GPU architecture dissected, more AI-focused cores, more throughput, DLSS and reflex upgrades, Go processor and a ton more. The NVIDIA Blackwell or RTX Blackwell architecture is designed specifically for gamers and content creators. This architecture will be offered on the RTX 50 graphics cards first, which launch later this month. NVIDIA RTX Blackwell Architecture Deep Dive. What we have known so far about the NVIDIA RTX Blackwell gaming GPUs is that they are based on TSMC's 4nm process node, feature up to 92 billion transistors with 4000 ITOPS, 380 RT flops, a 125 flops of FP32 compute, the fastest GDDR7 memory interface with up to 1.8 TB per second bandwidth, and come with a brand new Founders Edition design. With Blackwell, NVIDIA had a few design goals in mind to accelerate the graphical capabilities for the next generation of gaming. The architecture was to be designed and optimized around new neural capabilities and workloads. It aims to reduce the overall memory footprint. It also focuses vastly on energy efficiency, and all the while adding new quality of service capabilities. So Blackwell had to introduce a lot of changes, and the main ones include the addition of 5th general tensor cores, offering high-speed FP4 compute and up to 4000 ITOPS of performance, 4th gen RT ray tracing cores with up to 360 RT flops and designed for mega geometry, a next-gen AI management processor which enables simultaneous AI models and graphics workloads to be executed, a brand new Blackwell SM with 125 flops of peak FP32 compute, and the addition of GDDR7 memory, which offers the world's fastest memory speeds of up to 30 Gbps, on the RTX 5080. Other notable additions to the RTX Blackwell GPU architecture include DisplayPort 2.1, UBR20, PCIe Gen 5 support, and 4K NVENC with 4:2:2 colors. Diving into the Blackwell SM, we first compare it with the Ada SM, which was mostly optimized for traditional shaders, and most of its tensor cores were used either for DLSS or content creation apps. Ada also partitioned the FP32 cores into two blocks, one that could purely execute FP32 and one that could execute both FP32 and INT32 formats. With Blackwell, NVIDIA has doubled its INT32 GPU throughput, which can help accelerate workloads such as work graphs and shader execution, and 5th general tensor cores also offer the aforementioned doubled throughput. Other microarchitectural changes allow multiple workloads to be executed efficiently. Blackwell also improves SIR, shader execution reordering, by 2x by reordering the neural models and the standard shading models and putting the same work together in an organized fashion. These models are then passed through tensor cores, if ML models, or shared cores, if shading models, for final execution. GDDR7 also brings a much needed upgrade over GDDR6/X memory, offering twice the bandwidth and data rate of G6 memory with higher frequency and lower wattage. GDDR7 also supports PAM4 signaling, and the PCB materials used on RTX 50 GPUs are top of the line from an engineering point of view. This is the first full-fledged architecture for desktop PCs to utilize both GDDR7 and PCIe 5.0 materials in full conjunction. The new memory interface also offers twice the efficiency of GDDR6 in terms of PJ, but this will be very useful in Mobility Max-Q designs where efficiency matters the most. Moving over to the ray tracing enhancements, the 4th gen RT cores introduce various new capabilities, such as a triangle cluster intersection engine which replaces the previous triangle intersection engine, which is optimized for mega geometry and can handle clusters of mega geometry and standard geometry much more efficiently. The Mega Geometry engine also has a new triangle cluster compression format which can be decompressed using Blackwell's on-chip engine. Lastly, there's the new liner or swept spheres block which accelerates RTX hair and fur rendering. To sum things up, the new RT cores bring an 8x ray triangle intersection rate while reducing the memory footprint to 0.75x. The FP4 format introduced on Blackwell's 5th general tensor cores will offer up to 32x throughput versus the Pascal generation and 2x versus the Ada generation of GPUs. These new cores will be taking full advantage of neural shading and rendering techniques featured in next-gen AAA titles. This also leads us to the next topic, which is about Blackwell's scheduling and how it processes various workloads. In Blackwell, NVIDIA is introducing a new programmable coprocessor known as AMP which sits at the front of the GPU, and interacts differently with the different cores on the GPU while understanding what's running on them, what's being done on them, and scheduling precisely the specific workload for the right core. NVIDIA also talked about Blackwell's new power gating modes. In Blackwell, the entire clock tree can be disabled even while the GPU is active. So, if the memory system or portions of the memory system are idle, power savings can be achieved this way. Another way to save power is to disable logic and SRAM when entire engines are idle. Blackwell also introduces a secondary rail that separates the core and the memory system which runs them at different voltages and, for different workloads, captures more performance within a power budget. It also allows a 15x reduction in the time it takes from the rail gate to the core. The new railgate system is particularly useful in laptops as it reduces leakage by a major margin. A new aspect of Blackwell is also its accelerated frequency switching capability, which improves clock responsiveness by 1000x. For example, a workload such as physics which doesn't utilize the full width of the GPU can switch to a higher frequency, while a tensor core workload which can use the full width of the GPU can move to a lower frequency. But when the CPU hasn't fed the GPU with any work, Blackwell can drop frequency fast, and this is done because Blackwell can switch back to a faster frequency faster. In terms of clock frequency uplift, Blackwell achieves a 300 MHz higher frequency in active state versus Ada GPUs. Lastly, we have Blackwell's display and video capabilities. New support on Blackwell includes support for DisplayPort 2.1b. UBR20, with high-speed hardware flip metering which improves the pace of frames using DLSS 4. There's also the 9th gen encoder and 6th gen decoder, offering AV1 and 2xH.264 decode capabilities, while MBHEVC and 4.2.2 decode are also included in the RTX Blackwell video engine block. NVIDIA DLSS 4, continuing the deep learning innovations since the advent of DLSS back in 2018, the technology has been improving continuously. The DLSS model is being trained on a supercomputer housed within the NVIDIA HQ which is running 24/7 and uses the latest and greatest of their GPUs for the past 6 years. The last major iteration of DLSS was DLSS 3.5, which introduced tray reconstruction. This new feature was part of the failure process in which the model detects various issues such as blurriness, ghosting, and flickering. NVIDIA's in-house team of engineers then tried to figure out what went wrong in the model and why the image wasn't created as intended. New approaches are defined to augment the model set which is retrained and tested across hundreds of games to achieve the desired image quality, and these result in upgraded versions of DLSS, with the latest one now being DLSS 4, which improves upon all aspects of the supersampling technology. With DLSS 4, NVIDIA is transitioning to a completely new neural architecture model from 2020's DLSS 2. The main change is the new transformer engine which can be trained across multiple datasets while being computationally efficient, offering 2x the parameter size and 4x the compute horsepower. DLSS 4 also adds the new MFG mode or multi-frame generation which, instead of running 2 models per frame, runs 5 models per frame with super resolution and ray reconstruction. This leads to 15 out of 16 pixels or frames being generated by eye, all the while improving the image quality. NVIDIA also dives a bit into why they only thought of doing multi-frame frame-gen with Blackwell, and there were two reasons. One was that DLSS's image quality was not that great to begin with and needed more training time, while the second was the time it takes to generate these new frames could result in frame pacing and artifacting issues. So, as the DLSS model was trained, the image quality became much better, which is fairly noticeable in recent DLSS 3 and DLSS 3.5 titles, while for frame pacing, NVIDIA's flip metering system is the solution that displays frame, and this has been upgraded, and it can now reduce the frame variability by 5-10x, leading to similar or better latency versus last-gen DLSS solutions even when MFG is enabled. Best of all, while MFG will be limited to RTX 50 and frame generation will be limited to RTX 40 and RTX 50 series, the image quality enhancements and Reflex 2 highlights will apply to all RTX GPUs as we reported here, so all RTX GPU owners are in for a small treat even if they don't own the latest and greatest hardware. Unlike previous generations of DLSS, DLSS 4 will come with Day 0 support for a total of 75 games and apps, the largest library of DLSS-enabled titles on the first day and more on the way. To be clear, NVIDIA confirmed that developers will be able to leverage DLSS 4 quite easily if they have already integrated DLSS 3 or DLSS 3.5 within the engines. NVIDIA will also integrate the option to enable DLSS 4 for non-DLSS 4 titles such as those with DLSS 3 support within its NVIDIA app. You can select between the older CNN mode, which will be a little bit faster but with lower image quality, and choose between various frame generation modes such as 2x, 3x and up to 4x. Users can also select between resolution override modes such as DLSS if they prefer higher image fidelity, or go with DLSS Ultra Perf, which enables faster performance on RTX GPUs.